So we have a number 29 on a chapter test. So this is another base number problem. So it's actually quite interesting. So we have a 9 factorial expressed as an integer in base 9, and then that number has some zeros at the end, which is m zeros. And then the first number after the zeros, like before the zeros actually, preceding m zeros is n. So we like to find those order pair. So like if this like somehow challenging to you, I would say think about like the question was in base 10, like wish that this was base 10. Then if this question was asked in base 10, what would you do usually is like to see how many zeros at the end, it's just number of tens, right? And then number of tens is determined by number of fives and number of twos, and then you just need to find the number of fives or number of twos. But since we have more twos than five, we just need to know what number of fives. That's what like we usually do, right? But in this case, it's not base 10, it's base 9. So, but the idea is the same. So which is why I'll just say if you are looking for in base 9, like number of zeros at the end, so you just need to know how many nines you actually can make in 9 factorial, which is like number of threes will determine number of nines. So we just need to know how many threes in 9 factorial. So like there's way we usually count those, which I'm gonna do that first. And then let's go with that first. So that you take the 9 and divide by 3. So and then we take the floor of this, right? And then we have even name for this one. I'll just attach that to description. So why we do this one? We just say how many multiple threes in 9 factorial. So that will be just 3. So what are those numbers? Like 3, 6, and 9. But if there is some numbers like which is there is like more than 1 threes in it, so then you should count those additional threes as well, which we divide 9 by 3 squared, right? And then that will give us a total, because there's no like 3 threes in any number in 9 factorial. So this is going to be like 3 plus 1, which is going to be 4. So if you take the floor, so like meaning that there is 4 threes in 9 factorial, which is easier to count. But I just did this because if this was like 19 or 29 or a bit bigger number, then the things will be a bit harder to just go and count them. So which is why this approach is usually what we use. So then there are 4 threes, so we can make 2 nines, right? So which means if there are like when you multiply this, you may just make 2 nines, right? So that means there are 2 zeros at the end. Okay, so the m is 2 because you have 2 nines in that product, which will determine number of zeros at the end. Okay, so now we just need to know how about n, right? So the n is the first number right before the those 2 zeros at the end. So like, and now we are asking like if I take the 9 factorial, divide by like 9 squared, because like you have 2 nines in that product, and then if you just divide by 2 nines, you will actually remove those zeros at the end, and then you just get the last digit, right? If you divide by 9. So that's why I'll just say if I want to take the 9 factorial, which is 9 times 8, 7, 6, 5, 4, 3, 2, and 1. So this was my number, but we already take the nines, which means I will just remove all those threes, because when I remove those like threes, that means the number doesn't have any zeros at the end. So the question becomes, what would be the last digit of this if I multiply this and then find this in base 9? So I'm going to call this is x base 9. Okay, so because if you're looking for the last digit in base 9, you take mod 10. So now we are taking mod 9. So then we don't really want to multiply. We just need to know what that number is equal to in mod 9. So like one thing I can see easily, like 4 and 2 is 8. So 8 is -1. So I can just use that as mod power. And then that's also 8. That's also -1, which means that's just -1 times -1. Maybe I should write this here. So that's -1. And then you have 2 times 5. All right, 7. As it is, 2 times 5 is 10. But if you take mod 9, so that will be 1. So that's just the remainder when you divide by 9, basically. And then 2, 5 is 1. And then 4, 2 is -1 because that was 8. And if you multiply these two -1, just 1. So times 7 is just 7. So that become 7 mod 9. So which means my first digit before those zeros is 7. So the answer to the question should be 2, 7. Like this is like straightforward. I would say this is the slick way to do this problem. But if you kind of don't really buy this, and then this is number 29 on the test. So if you don't really think this immediately, then you just convert this in base 10, which is probably not hard to do. So either. So that is what I'm going to do now. So if I take 9, 8, 7, 6, 5, 4, 3, 2, 1, we can just pair some way to make it easier to multiply. If you do this, you will get 36, 28, and 80, I guess. Just manually multiply those. Okay, so then what we're going to do, this is the number in base 10. We just need to write this in base 9. So there are a couple of ways people use to convert into different base from base 10. So one way is just the dividing. So we take the 36, 28, 80, and then we divide this by 9 because we are converting into base 9. And if you do that, so you will get 40,320. Again, this is just division, so without calculator, but it's going to be a bit tedious. And then we will have a remainder of 0. So let's keep that in mind. And then if I take now this number, 40,320, and then divide this by 9, so we do get 4,480. And then we do have a remainder of 0 as well. Like you can just kind of see that immediately because for the remainder, so if you add the digits, so 8, 8, 16, so plus 2 is 18, 0.4, 27, the digit sum is 27. So since this 27 is multiple of 9, multiple of 9, that should be divisible by 9, so we should get 0 as a remainder. And then when you divide 36 by like 9, you got 4, and then you can just do it in your head if you can. Otherwise, just do the long division. Now we are going to divide this again by 9, so you should get 4,480 divided by 9. So in this case, you got 497 with remainder of 7. Okay, and then now we have 497, and then we divide this by 9. So you got 55 with remainder of 2. And then we have 55 divided by 9, so that should be like 6 times. That's 654, and then plus 1, remainder of 1. And lastly, we take 9, which, 9 doesn't goes into, 6 doesn't goes into 9, so you should get 0 times, and then remainder of 6. So again, this is one way we use to convert into different bases. So we start taking these remainders. So that should be 1 and then 6, right? So then this number, I'll say 36, 28, 80, which is in base 10. This number is equal to 6, 1. Okay, 6, 1, and then 2, 7. So 7, 0, 0. And this is base 9. So like if you remember, we just said like there are 2 zeros at the end, so which is like 2 zeros right here. Then that is our like M. And then right before those 2 zeros, the digit is 7. So that is still 2, 7 as before. Like this is not too bad to be honest for this problem, but as you see, you just need to get that 9 factorial in base 10 and then just divide by 9 a few times, which is not too hard. If you kind of didn't see the first approach, this is still valid, especially if you like to get the number 29 correct, why not? So that would be another solution. But again, if this is a bit larger number, then the second approach doesn't look feasible. So I'll take the first one. But anyway, I'll see you in the next one.